Hello, everyone, and welcome to my lab. I'm so happy to see you here. I promise you a good time. Are you ready to learn? Yeah. Are you ready to have fun? Yeah. Well, that's what we're going to do as we do a lot of fun experiments. We're going to do now a whole bunch of experiments with a very cold liquid. We're going to dive way down the temperature scale and go to a temperature of minus 196 degrees Celsius. Liquid nitrogen is a very cold substance. Its temperature is minus 196 degrees Celsius, which is about 320 degrees below 0 Fahrenheit. So it's really, really very, very cold. And the experiments that we're going to do are experiments where we're going to, well, first of all, we're going to use some liquid nitrogen. I'll show you the liquid nitrogen. It's kept in these thermos bottles that we call, in science, we give them a technical name. They're called Dewar flasks. And there's the liquid nitrogen. It just, when it hits something warmer than minus 196 degrees Celsius, it simply boils off. So what we're going to do is cook a whole bunch of different things with liquid nitrogen. And so first thing we're going to do is make some coffee. So there you see the coffee is almost ready. It's quite ready. The next thing I'm going to do is fill this very big thermos bottle. I'm going to fill this with some liquid nitrogen. This is evacuated, but it has a big hole in the middle here, which is going to be used for putting the liquid nitrogen. I have more liquid nitrogen, which I put in there. What's the stuff coming off the top? It's condensed water vapor, right? And you see the liquid boil. That's because the temperature of the Dewar flask is higher than the boiling point of nitrogen. And what we're going to do now is cook a whole bunch of different things, like we made the coffee first. Well, before I cook anything, I'm going to take this very bouncy rubber ball, right? I'm going to put it in there. And also, I'm going to take a banana, put a banana in there. Actually, I'm going to put 2 bananas in there. Okay, 2 bananas in there. And next, what I'm going to do is, right here, take these out of the way. What I'm going to do in this small beaker, I'm going to take an egg. Just an ordinary egg. See the egg? Okay. I'm going to put it in the beaker very gently. And then I'm going to put some liquid nitrogen on. And I'm going to cook the egg. We're just cooking at minus 196 degrees Celsius. That's what we're doing. I'm going to take now, also out of this other beaker, I want to take these small pieces of rubber. You see, they can be stretched very, very easily. And put them in the beaker and add some liquid nitrogen. You see, the liquid boils and boils. Oh, we need more over here. We're running out, so we go to the next one. As long as the temperature of the objects that are in contact with the liquid nitrogen is higher than the boiling point, then we get this boiling. So what I will do now is see if I can fish this out. Actually, I'll come out to the other side and try to fish it out. And see what happens. So here's the ball. I'm trying to fish it out. Oops. Not so easy to fish out. There it is. And I can handle it rather okay with these gloves. What I'm going to do, I want you to watch this very carefully. I'm going to bounce this ball now off the floor. So you ready? Here goes. Did you see that? Huh? The rubber froze, and when rubber freezes, it loses its elasticity. It's no longer bouncy. And so what happened here is that the hard rubber, when it hit the hard floor, then shattered. That's what we call a shattering experience. All right, all right. I'll make it up to you. I'll make it up to you because I want you now to look at that in slow motion. So take a quick look now at the... There you see the ball, and there you see it's breaking into small pieces. All right, so let's go back and see what's happening to our egg that's being cooked in here. So we try to get the egg out. All right, here comes the egg. Liquid nitrogen first. Look what happened to our egg. Our egg has cracked, and some of it has frozen. Some of it is not. It just looks like the eggs that you get in the dorm for breakfast, right? Oh, you recognize those. Okay, I'll put it back in here before it makes a big mess. Now, we still have the bananas in there, so let's reach in and get the one of the bananas out. Can't use that. That's the one I want to use. And this is a very hard and stiff banana. And what I'm going to do is take a piece of wood and get some of these pieces of rubber out. And I'm going to take a piece of rubber and use the banana as a hammer. Whoops, the banana broke. And so here's a rubber nail through a piece of wood. Here's another one. Let's try another one. So a bunch of rubber nails in place, as you see. Okay. What I'm going to do next is look at a bunch of different experiments and do some different experiments that involve some household chemicals, things that you can do at home. This experiment is one where you take a cylinder, a tall cylinder like this, and you have 4 different chemicals. The first one that you use in doing this experiment is honey. Did you know that honey is a chemical? Did you know that everything around us is made up of chemicals? The food that we eat is made of chemicals. The air that we breathe is a mixture of chemicals. So you take some honey, and it flows rather slowly. And you put a little bit of honey in there, not much, just a little bit. And the next thing that you add is some water. Water is a chemical too. And you see the water floats on top of the honey. The next chemical that you take is some oil. And you add the oil. And you know that oil and water don't mix, right? And so the oil floats on top of the water. And the third thing that you do is you take some isopropyl alcohol and you add that gently and slowly, and you see that the isopropyl alcohol floats on top of the oil. So we have made now 4 layers of 4 different liquids that are immiscible with each other. They don't mix with each other, and you can see those layers. In chemistry and in other parts of science, we have many, many examples of such behavior, which is rather interesting to look at and wonder why different things don't mix with each other while other things actually mix quite well. I have an example of a different set of chemicals that have been already prepared. I'll put them right next to this one, where you can see that we have 4 layers. We added food coloring to the top layer and to the second layer. and not the same chemical that I used here. There's so many different examples that one can use if one understands the behavior and the properties of these different chemical systems. Okay, so let's move on and do some other experiments. Let me get these things out of the way. And I'm going to do now these experiments right over here, where I will take a pot that has in it some boiling water. This pot has had this water boil for a long time. I need to reach for my gloves, to put my gloves on to touch it. And what I'm going to do is take the hot boiling water. I'm going to quickly lift it off the heater and then stopper it right away. So do that, see? And I stopper it like this. And it's nice and tight. And it's quite hot, I can tell you that. And then I'm going to flip it over and put it inside this tripod. And you notice that the water has stopped boiling. There are just a little bit of, there are a few bubbles down there that you see. And what I'm going to do next is take a bucket of ice, and I have an ice bag. And what I'm going to do is put the ice bag up here. And I want you to look now at the water. And I've made the hot water down here boil by putting a cold bag of ice on top. And I want you to think about that. I want you to think about why this happens and why different things that we not only see in my lab but in other labs happen the way they happen. So I'll move some of these things again out of the way and look at a bunch of different substances. Instead of using the hot plate for heat, I'm going to now use this big burner to heat some of the water that I'm going to put in a big can. I'm going to take this out of the way, and I'm going to get a big can, and I'm going to turn the Meeker burner on, and what I'm going to do is heat this can. But before I heat this can, what I want to do is put a little bit of water in it, and I'll heat the water in the can. So here it is. I take the water, put the water in like this, set it up there, and allow it to heat for a while. What we want to look for is condensed water vapor coming out of the opening. When the condensed water vapor comes out of the opening, we know that the water inside has been boiling. At the same time that I do that, I want to take a small can. Look at this. This is still boiling over here. It's rather interesting how that works. I'm going to take a small can, a small soda can. I'm going to put some water in this can too and heat it on the hot plate. And once again, I will look for condensed water vapor to be coming from the top to know that the heating has taken place. As all of this is happening, I want to try to wait for the water to boil. I want to do a different experiment that you can try to do at home. If you have a balloon, everybody can get a balloon. And if you have a hairdryer, everybody can get a hairdryer. Okay, well, this experiment is very simple. What you do is you turn the hairdryer on. You can hear it. It's on, right? And you know there's a jet of air coming out, right? And it's hot air, unless you push the cool button. It has a cool button here, so it's cold air. And then you take this balloon, isn't that? This is special, not a special balloon, just an ordinary balloon. And you put it on top like so. And you then increase the blast. And there's the balloon being held up by the jet of air coming out. If you put your hand in the way, it comes down. And you put your hand in the way again, it comes down and goes up again. And what you want to think about is why does the air that's rushing upward hold the balloon up, and why doesn't the balloon keep going up, and why doesn't the balloon come down? We do experiments in order to try to find out answers to questions of that type. Now, all right, let's check on this and see, do we have any? Yeah, there's some condensed water vapor coming out, but not enough. So we're going to do, we'll wait for a little longer. I'm going to do another set of experiments. Oh, I have some bananas left over here, which I will put away. What I'm going to do next is take a look at a, you ever wonder why it's hard to get the ketchup out of a bottle of ketchup? Huh? And everybody's had that experience, right? What you have to do before you get it out is that you have to shake it. Well, there's some substances that liquefy when we agitate them. And when we don't agitate them, they go back into a gel form. And a good example of that is ketchup. We all know that we really have to shake this very well before any comes out, right? I haven't shaken it well enough here, but that's what we know we have to do. There's some other substances, common substances, that behave in the opposite way. And one of them is starch. So if you take a small amount of starch, like 2 parts of cornstarch, and add some water to it, and you end up with a slurry that has cornstarch in it. And you'll notice that the cornstarch is rather, it flows rather easily. If you try to pick it up with a knife, like I'm trying to do now, it's very hard to pick up. So this behavior is when you agitate the cornstarch slurry, so I squirted some out, right? When you agitate it like that, it's the opposite behavior of the ketchup. And then when you let it sit, you see it becomes more liquidy than it was before. So another example of this very same behavior is experienced when we walk on wet sand. Everybody's walked on wet sand one time or the other. And the wet sand appears to dry and becomes firm as we walk on it. That's the same kind of property as the one that we are looking at here. So in everyday common experiences, we want to think about chemical behavior and scientific behavior and try to explain the behavior of different types of substances like the ones that we are looking at right here. So again, we look now at take a look at the top of the opening. We see some condensed water vapor coming out. We want this to boil a little longer before we do the experiment. What's happening with this one? It's getting hot, I can tell you that, but it's not boiling as yet. So as we wait for that to happen, I'm going to do another experiment. And this experiment I'll do in these 2 jars. This first jar that has in it the clear and colorless liquid has water in it. And this other jar has a polymer in it. Polymers are substances that are very important to us. Everybody knows about polymers because you know about nylon, Orlon, Dacron, and so on. Water is an example of a substance which is not polymeric. I'm going to take this small flywheel and I'm going to put it in the water and stir it up. And as everyone knows, what happens down the middle is that you see a vortex when you go fast like this with a liquid such as water. So the next thing I'm going to do is take this out and dry it because I want to put it in the polymer and see what happens as we turn the wheel inside this polymeric solution. So here we go. We turn it. And you can see that the polymer liquid is rising. This is rising, is climbing the rod, basically. And that's an interesting property that's commonly observed by bakers. Now what I want to do, I want to show you the same kind of reaction on a bigger scale. I want you to look at this assembly, which has a very smooth shaft and a crank on top, and it's dipped into a different polymeric solution that has food coloring added to it. So the shaft is very, very smooth. And watch what happens when I turn the crank then. As I said, this behavior is commonly observed by bakers because when dough is mixed in an electric mixer, for example, it often climbs up the beater and collects around the shaft. Ask any baker about this, or ask anybody who does some baking, and you notice it yourself the next time you try it. This is a property that is peculiar. It is characteristic of substances that's in the baking business, for example, that are starchy. The solvent that we use is the water, and starch is a polymeric substance that climbs up the rod in the fashion that I have shown you here. All right, let's take now a quick look at the big tank. Yes, we have a lot of condensed water vapor coming out. And what I'm going to do is take this empty trough. I'm going to put it right here. I'm going to reach for some ice, ordinary ice. Put the ordinary ice in, like so. And then what I'm going to do, well, I guess I need a little more ice, so let's add more ice. Then what I'm going to do is reach over for the tank, this big can, but it's hot, so I have to put my gloves on, right? And what I'm going to do is take a rubber stopper and stopper the hole and then lift it off. Stopper it and tighten it, and I'm going to put it on the ice, and I'm going to leave it alone. And we'll see what happens to it. Is anything happening to it? What? The can seems to be what? Well, let me turn it this way so you can see. There it is. See that? The can has collapsed. Now, the can has collapsed. You saw that with your own eyes, right? It must have collapsed because the pressure inside the can is lower than the pressure outside the can, right? So how did the pressure inside the can get to be lower than the pressure of the atmosphere? It got to be lower because when the water was boiling and the water vapor was escaping from the opening here, it was driving along with it some of the air molecules. And so the pressure inside the can got to be lower than it is outside. And when I stopped it quickly, you saw what happened. So the atmospheric pressure is a very real quantity. It's huge, and you can see what it does. Now, let's take a look at the small can. We'll take this out of the way, and we'll take a look at the small can and see what can happen with the small can. What's going to happen with the small can? Well, let me show you what's going to happen with the small can. What I'm going to do is lift the can. I'm going to lift the can, and with this pair of tongs, I'll flip it over and put it in this tall form beaker that has water in it, and you watch and see what happens. Okay, you ready? Here we go. I hold it like this. Did you see that? What happened to this small can is that it also collapsed, right? It collapsed because the pressure, you like that? Now, you see, this is an experiment that you can do at home or in school. You don't need a big can like that. You just take an empty can, put a little bit of water, soda can, put a little bit of water in it, let it boil for a while. The water vapor escapes, right? It condenses. You can see it when it's coming out. And then you lower the pressure inside, and you get this very interesting effect, which I want you to look at in slow motion right now. So let's take a look. There's the can coming in, and put it in, and boom, there it goes. Isn't that neat? Well, what we've done now, is a whole bunch of experiments with solids, liquids, and gases. I want to wish each one of you the best in doing all your scientific experiments. Remember, no matter what you do, science is fun. Thank you very much.